All right, so this topic is going to be more about solving system of linear equations using operations over on a on a on the matrix of the system. So that's why it's system of linear equations matrices. So let's talk about the definition of a matrix, right? A matrix is a rectangular array of numbers, or a table that has numbers, right? But each number has a significance, like there is a meaning for each numbers. That's what I meant. So, like, let's say, for example, this number right here, right? This number is the number that is in the intersection of row one and column one. So that's why you see that it's A11. The first number is the row location, and the second number is the column location. So for example, if I see A32, I understand that it's not the same as A32, right? These are locations of the row and 2 3 locations of row and column, right? So that means this one means that's the number located in row 3 and column number 2, while this one is the number located at the intersection of row 2 and column number 3. And you can see all the numbers here. Like, you see how this one is 1 1, 1 2, I mean 2 2, and so on. It goes down and until you get the AMN. So that means the number of row of this matrix is M, and a number of columns of this matrix is N. So that's why the last number at the bottom right corner is MN. Now, let's talk about one more thing that is really important as we are talking about about the array of numbers in as a matrix, right? So basically what we've said here is that the number the numbers the number you are seeing at the foot of the numbers, they indicate the location of in terms of the location in terms of row and and location in terms of row and columns for each number. So say for example I have just take any example here, this one. So that's the number at the intersection of a at the intersection of the j of the row ith row and the j column. All right. So I think that now you will find you're okay to read a matrix. Now let's talk about an augmented matrix. An augmented matrix. Well, for each system, we will have to create or write out the matrix of the system, right? But since the system, if you remember, will be a number of equations, right, with a number of variables. Now let's see what the augmented matrix is. It says an augmented matrix of a system of a system of equations or linear equation is a matrix of numbers in which each row represents the coefficient. Each row represents the coefficients of all of the variables from one equation, and each column represents all the coefficients for a single variable. So say, for example, this is the coefficients for all the x's. This will be coefficient for all the y's, and so on. And this will be all the coefficients for the equation number one. I'm saying number one, and so on for number two. So in column, you have numbers that represent the coefficient for a single variable, and in row, you will have the coefficient for one equation. So that said, we're not finished yet. You need to make sure that you reorder the terms of each equation so that same variables are on top of each other, with the variables on one side and the constant on the other side of the equal sign. The last column that will be on the other side of the equal sign will be placed on the table, or on this table of numbers, separated by a dotted line. So when you do all of that, you put all the variables, all the coefficient of one variable on columns, and then that will end up giving you all the coefficients for each equation on the lines. Separate the column of variables to the column of constant on the other side. It creates what we call augmented matrix. Now, if you understand that, let's go ahead and create the augmented matrices for these two systems. So A, we're gonna create the augmented matrix of the system is what? So we're gonna create that table: 3, -4, dotted line, and then -6, so on. We're gonna do the same thing for the second equation: 2, -3, and -5. So this is the augmented matrix for the system A. And as you can see, you see how those are the coefficient of x, they are on the same row column. Those are the coefficient of y, they are in the same column, separated by the dotted line. And then you have the other side of the equation over here. So we can follow the same process to write the augmented matrix for the second system. The second system here, we have so it's a system of 3 variables, 3 equations. So we have 2, -1, but we must make sure, I almost forget, but we must make sure that we reorder the variables and make sure that they're each on top of the other. So basically, x is okay, but Y's are not okay, and Z is not okay. On the other side, we don't have all the constants. So we want to make sure that we do that. So go ahead and do that. So first equation, we had 2x minus y plus z equals 0. That's okay. And then we're going to look at x, the second equation. No x, no y, we skip it. So that's plus z equals, it's -1, we move it over, it's +1, so +1. And the last equation, we're going to do the same thing. We got x, no z, so we put plus y, and then no z, we skip it, and that's 8 equals 8. Now that I have this, anything that we skipped, we're going to make sure that we replace it by 0 in the table. So we have that. X equals 2 for the first equation. Y equals -1. What x, coefficient of x is 2, not x equals 2. Coefficient of x is 2. Coefficient of y is -1. Coefficient of z is 1. And the dotted line to create to put the other side of the equation, so we can, and that's pretty much the reason why they call it augmented matrix, because you're gonna have the other part of the equation on the other side, so that anything you do with the first one, you can do it with the second one too. Just like when you have an equation. So that is 0, right? And then now we can close, because everything will be inside. So then the second equation, coefficient of x is 1, y is not there, so that's a 0, and 1 for the z, and then on the other side 1, and then 1 1 0 8. So this is the augmented matrix for the system in B. Okay, so now let's see if we can do it backwards, right? I give you the augmented matrix, and then you're going to give me the system. So for the first one, A, we're going to create the system. These are the coefficients of x. So these are the numbers you will find in the first equation, right? So that's 5x plus 2y equals 13, -3x plus y equals -10. So that's A. And B, the system of 3 variables, 3x minus y minus z equals 7, 2x, no y, skip it, plus 2z equals 8, and then no x, so that's going to be y plus z equals 0. So that's a system from the augmented matrix of in B. All right. So now let's talk about operations on an augmented matrix. So when you have an augmented matrix for a system, what you need to focus on is what type of operations I can perform. And we have them here. Row operations are the following. First, you can interchange rows. Say row 1 can interchange with row 2 or row 3, for example. So it depends on what you need. If what you need, row 3 offers it to you better than row 1 being in its place, then you can interchange them so you can get the better result or the result you're looking for. And another operation you can do is that you can replace a row by itself times a number that's not 0. Itself by a number that's not 0. Say I'm gonna replace row 2 by, A times row 2. A being a number, right? A being a number, not you can replace a row by A times another row. No, you can replace the row by A times itself, where A is not zero. A cannot be zero. Also, another operation you can do is you can replace a row, one for example, by itself plus a combination of another one. So say A times or 3, where A obviously is not zero, because if it's zero, then it's still going to be the same row. Those are the 3 operations that you can perform in order to get some results that we're going to talk about later. But here's an example of performing operations. So this one, they say they want you to perform this operation to create a new augmented matrix that is equivalent to this one that we're looking at. So let me write it over here. So that's 1, -2, 3, -5, and then obviously we need to add the other part of the equation that is on the other side. So we have that, and then the other side is 2 and 9, right, in column. So I'm going to work this operation. Row 2 receives row 2 plus 3 times row 1, right? So then row 1 is not going to change, right? The only row that is changing is row 2, because the row that is receiving is the one changing. The row that is receiving is changing, and the row that is not receiving, if a row is not receiving, then it's not going to change. So let's see what this operation leads us to. So row 1 is not changing. I'm just going to copy it down. So 1, -2, dotted line, and 2. Now they say we're going to perform this operation. Row 2 receives row 2 plus 3 row 1 plus 3 row 1. So is it plus or minus? It's -3 row 1. -3 row 1. So row 3, row 2, so 3 -3 times the value in row 1, that's 1. And then they also say that they want us to perform that other operation that say, I mean, same operation, but we needed to do it for each row, each part of the row. So that's -5 -3 times -2. And then do it on the other side as well. 9 -3 times 2. Then we can solve it to get the first row remains the same, 1 -2, 1 -2, and 2. And then here, that is 0. And that is 1, because that's -5 plus 6, 1. And then that is 9 minus 6, that is 3. 9 minus 6, 3. So then that's it. We performed this row operation to get this new augmented matrix. And also, if you perform one of these operations, it creates a new augmented matrix equivalent to the previous one. Now, one more exercise you can do with using these operations is that you can you can find, you need to be able to find the operation that will give you results that you want. So say here, they say you want to find 0 in row 1, column 2, zeros. Well, one thing we want to add on that too is that you want to do it without changing anything in the main number, in the on the numbers in the main matrix, except for really what you want to change. So you want to perform this in order to find this result. But because if you mess up the things that were already done, then it messes up the whole thing. So you want to keep 1 and 0. You want to keep this one on the first one and 0 on the remaining numbers. So what is this operation? Well, we can perform row 2. We want to have row 1, column 2. So we want to make row 1 receive. Row 1 will receive, because we want 0 here. If you want 0 here, what do? Would you not do -2 plus 2 times 1? So that means you would do row 1 receives row 1 plus 2 times row 2. Yes? Okay. So that's the same result that we found. So I can copy my result here, bring it here so we can work with it. So that's the same result we had. Just going to work with it and perform this operation. So, and copy my operation here. So that's the operation we want to perform. So that's this. Row 2 will remain the same, but let me work with row 1. Row 1 is row 1 plus 2, row 2. Row 1, that is 1 plus 2 times row 2, 0. And then here, -2 plus 2 times, -2 plus 2 times row 2, 1. And then do it for the other side as well. We'll do it for the other side as well. And then the other side will be it will be dotted line, will be 2 minus, plus 2 times 3. All right, so now we can write the second row. That's 0, 1, and 3, because we're not changing that 1. We're only changing the 1 with the row 1. That's what we're changing. So let's perform these operations to get to see what we get here. So then the end result will be 1 plus 2 times 0. That's 1, because 1 plus 2 times 0 is 0. So 1 plus 0 is 0, 1. And then -2 plus 2 times 1. 2 times 1, 2. So to make -2 positive 2, that's 0. And then 2 plus 2 times 3. 2 times 3 is 6, plus 2, so that's 8. And then 0, 1, and 3. So that is what we get in result for this operation. Now, what we need to see here is, and the question that we want to ask is, why do we need to perform row operations? Well, this is where we were coming. We were coming to this point where we can perform row operations so we can solve a system of linear equation. Now, how does that work? First, you need to make sure that the entry in for you need to create what we call a row echelon form of the main matrix, just like we have here. So you can see the row echelon matrix will be a matrix where you have 0 below the diagonal principal, the main diagonal. So say, for example, this is your main diagonal, right? I don't know how it's going to come out, but that's what I'm going to try to show you. That's your main diagonal. Say that this is your main diagonal. Well, when you're creating a row echelon matrix, you can have numbers right here. It's okay to have numbers here. But all the numbers here, you want them to be zeros. And once you do that, you're almost there. But you also have to have ones on the main diagonal. So a row echelon matrix is a matrix where you have only ones on your main diagonal, and then below the main diagonal, you have only zeros. That's a row echelon matrix. Ones on the main diagonal only, and then zeros below the main diagonal. So that said, you need to perform. And the process for you to do that is you need to start with this one, make it 1, and make all of these zeros. Make this one 1, all of these zeros. And then next 1 and all of these zeros. And you want to work on it row by row. So row 1, make it 1 on top and then zeros below. The second number in second row, you want it 1, and then the bottom numbers zeros, and so on. If you can do that, then you're ready to solve system of equations using row operations. So that said, and these are the steps here. So first, you need to write your augmented matrix of the system. Next, you need to do the work for row 1 on top and zeros at the bottom. Next, so row 2 and so on. And once you get your echelon form of the matrix of the system, then you rewrite your system with this new matrix because it's equivalent to the previous one. Now you're going to be able to go from the bottom up, solving for each variable. So let's see what we see in this example. First, we're gonna start writing the augmented matrix for this system. So that's going to be 2, 2, 0, dotted line here. So we can separate this. And then we got 6 over here. All right, so that's the first thing that we do. And let's deal with the second one. So that's 1, 1, 1, 1. That's pretty nice. And 3, 4, -1, and 13. Now that we have this, we're going to make sure that this is 1. Remember, we are free to decide what we do, but our own choices can complicate our lives. That's why before you start performing your operations, just try to take some time to see the best opportunities, the best scenarios that can help you. Well, you can do whatever you can. Some of them will imply you doing more work than the other. So that's why you need to pick the right option when you're solving. Well, I mean, I see that it's all ones on column number 2. And then I want 1 right here, right? If I can move this one up here, which is one of the operations that are allowed, right? The first one is the interchanging the rows. Well, why not doing this? And that will not be an issue for me. So basically, I would go with this operation. R1 receives interchange with R2. And then that's almost the same augmented matrix. So I copy this and then bring it over here, which will be now, instead of having this row here, I'm going to have it up here, and then that one will take the second place. So that's what I have here. And then that. Okay, I have one. I have one right here, and that's what I wanted. That's the first move you do. Always want the one in the top left corner of your for A11. A11, you want it equals 1. So now next move is that I want to have zeros for all of these, right? I'm going to perform 2 operations quickly to zero them out. So the 2 operations will be R2 receives R2 plus minus 2R1, and R3 receives R3 minus 3R1. Those will not mess up the one that I already created in first row and first column. Also, they're going to give me the 0 that I want, right? So that is also helpful for me. So let me go ahead and copy this one, right? And then I'm going to make sure that this operation is the next thing that I do for this. All right. So then that will take me to this next. I know row 1 will stay, but let me work with the ones that I am going to change. So row 2 minus 2 row 1. So that's 2 minus 2 times 1, right? And that's 2 minus 2 times 1 again. That is 0 minus 2 times 1 again. And then the dotted line, and then that is 6 minus 2 times 1, right? Okay. Now, let's put the first line, that's all ones. So 1, 1, 1, 1. And the third row will receive this combination. So that is row 3 receives row 3 minus 3 times row 1. So that's row 3, 3, minus 3 times row 1, 1. Row 3, 4, minus 3 times row 1, 1. And row 3, negative 1, minus 3 times row 1, 1. And then row 3, 13, minus 3 times row 1, 1. Okay, now let's simplify this. So we have, this is going to be 1, 1, 1, dotted line to separate, and then 1. And then now let's perform this. That's 2 minus negative 2 times 1, negative 2 minus 2, so that's 0. 2 minus 2 times 1, that should be 1. That's 1. That's 1. All right, so that's 0. Another 0. And then you also have that's negative 2, and that is 4. That is 0, which is cool. And that is 1. That is that is -4, and that is 10. That's pretty cool. That we can move on with that. Let's see what we can do now. Remember, that's perfect that we have these zeros, 1 on top and 0. Now, what else we need? We do need to have a 1 right here because we are trying to get 1 on the main diagonal, right? So the next, after you finish clearing your first column, you want to work with the second column, right? First column is fine. I have 1 on top and 0 at the bottom of 1. And then now we want 0 in the second number of column 2, second row, second column. It's a 0 now. But below it, I see a 1. I can change again, right? I can move the row 3 up to row 2. That's another transformation that we can do. So let's do row 2 interchange with row 3, right? So that means I'm going from this problem, this matrix here, and I will perform this operation here to get the result that I want, right? So basically, I'm gonna keep my same, pretty much my same problem, but what's gonna happen is the second row will change to the third. Right? So that's what I have. That's another operation that I just did. And what's cool with that is the fact that we already have it. The 0 is already the next below the 1. It's a 0, and that's what we wanted. The only thing that we need to finish is to get 1 here. Where do you get 1? I think we can do this operation, the second option here, that you can make a row receive itself times something, right? What would you multiply by row 3 to make this a 1? I would multiply it by -1/2. If we multiply by -1/2, we automatically get a 1, and that's what we want. So we would do this last operation, that is row from this matrix. The previous one, we would perform row 3 receive -1/2 of itself, right? So that takes me to this, right? So I'm not gonna make any change on row 1 and row 2, right? Row 3 is the only one that's going to change into -1/2 of itself, right? So that's going to be -1/2 of 0, 0, -1/2 of 0, 0, and -1/2 of -2 is +1. Is 1, and then -1/2 of 4 would be -2. -2. So now the fact that I have 1s on the main diagonal and 0s below it in general, I can go back to my system to rewrite it again. So let's rewrite the system using the row echelon matrix, right? So what do you see? Now it's going to be x plus y plus z equals 1. That will be 0 for x, so that's y minus 4z equals 10, and then Z equals -2, which automatically gives me the value of Z. Z equals -2. Now from Z equals -2, I can go up to the second equation to find the Y because I know X, and it's only the second equation, it's only X and Y, so I can find Y, Z and Y, I can find Y. So that's Y, we add 4Z on both sides equals 10 plus 4Z, right? So that Y equals 10 plus 4 times the value of Z, -2. So that is 10 plus minus 8. And then that equals +2. Y equals +2. I have Z and Y. I can find X because the first equation is XYZ. So that's going to be X equals -Y minus Z plus 1. So X equals -Y, so that's -2, minus Z, which is -2 plus 1, and X equals -2 plus 2 plus 1, so X equals 1. X equals 1, so that's your solution. That is X equals 1, Y equals 2, and Z equals -2. So that's the solution for this system, and it's a unique solution. Let's try this other example. We're gonna start first writing the we're going to start writing the augmented matrix. So that is 1, -1, and 1. And then you have 8. So that's negative, that's 2, 3, -1, and -2, 3, -2, -9. Okay, we already have 1, right? So we can perform the same operation that we had earlier to this one, so we can zero the other uh the numbers below the one in the first column, right? So we will do row 2 receives row 2 minus 2 row 1, and row 3 will receive row 3 minus 3 row 1, right? Because those will make it all zeros. So that's 1, 0, 0. We already see that's what it's going to be. And then -1. So for the second, let me finish the -1, 1, dotted line. And then 8, right? So let's change this. So that's row 2, which is 3 minus 2 times -1. So that is 3 plus 2, that's 5. And then the number after the next row will be, where is, that's -9, and that's +9. So that is row 2, -1 minus 2 times 2, well, not 2, 1. That equals -3. right? And then last row 2, -2 minus 2 times row 1, that's 8. So that's -2 minus 16. So that's -18. And then we are trying to write the second operation here. That's a -2 minus 3 times -1. Row 3 minus 3 times row 1. So that is -2 plus 3, that equals 1. And next, row 3, -9 minus 3 times row 1, that's 1. So that's -12. And then row 3, 9 minus 3 times row 1, 8. 9 minus 24, it's 9 minus 24, that's -14. Well, this going to be -15, -15, because we had 9 minus 3 times 8, right? 9 minus 24 equals -15. So that's -15. Um, so we're going to try to fix this. Should be -15. So, all right. So now we're going to perform some more. Um, we're going to perform some more uh, operations so that we can get this. We're almost there. We're almost there. We only need to get a 0 underneath of 5, and then a 1 underneath of -3, and that makes the deal. Now, what do we do to make a 0? What operation that we can think of that would make a 0 underneath of 5? I want you to concentrate on the fact that these two first column, the first column underneath of 1 are zeros. Then you can play with them without changing the other numbers in the column, right? So play with row 1, row 2, don't go to row 1. Play with row 2 and row 3, and while you're looking at 5 and 1 to see what operations or what operation you can incorporate to get this answer that you need. Well, I was giving you some hint. Now let's see what we do. So we're coming from this to get this is what we get. Now we want to perform an operation to get a 0 right here. So the operation must be, this operation must be row 3, because that's the one we want to be 0, will receive row 3 itself minus 5 times row well, we have not done we need to get a 1 first. We need to get a 1 here. But it's easy to get the 1, right? By just trans uh uh interchange by just interchange 2 and 2 and 3. Let's interchange 2 and 3. So then that's going to be when we interchange 2 and 3, we will get, let me copy 3 and pull it on the outside. So I can move. Okay. And then I'm going to move 2 down. Right. And then 3 will be 2. And it automatically gives me the 1 underneath of the in the second row and second column. Now I need 0 underneath. So now I can perform from that. Oops. From that, I can copy this, can go here, and then perform the operation where I'm gonna make, oops, there's a problem here. So 1 will still be 8 over here. And that's 8 also. There's a problem when I was copying, but now it fixed. So I want row 3. I want that row 3. I want it to receive itself minus 5 row 2. So then that will give me one of the things that I really want to have now, which is 0 underneath of the 1 in the third row and second column. So since I'm changing this row, let me so this row, I'm going to have a 0 right here, a 0 here, and then that is 57, and that also will be 57. That also will be 57. You can do the math to get that. And then now, last thing to do is to make this one, perform this one. From this one, I can perform the operation where I'm gonna make row 3 receive 1 over 57 of itself. Okay, and then that's it. That will make the deal to get the row echelon. That will give me the row echelon matrix that I want to solve the system. That's a 1, and that also will be a 1. And the row echelon matrix, the system from the row echelon matrix found, is x minus y plus z equals 8, y minus 12, z equals negative 15, z equals 1. Obviously, that's z equals 1. You got the z, and from that, we can get z into this. So that gives me y minus 12 equals negative 15. So y equals 3. And then y and z into this. That's 3 of x equals x minus 3 plus 1 equals 8. So that gives me x equals 8 plus 2 equals 10. Oh, let's see again. Let's see again what we get. That's negative y, negative 3. Uh, I got z equals 1, y equals negative 3. Y equals negative 3. Obviously, yes, y equals negative 3. So that's plus here. All right, and then so that is x equals 4. And the solution is x equals 4, y equals negative 3, and z equals 1. So in the next video, we'll go over these two more problems, and that's going to finish this lesson, and we'll start with lesson lesson 3, which will be determinants. But we'll do another video for the next two examples.